All right, good morning or afternoon, everybody. It's Mr. Geiselman again, here to talk to you about circuits. So here we go. Circuits are a set of electrical pathways or electrical parts that are connected to provide a pathway for electrons to flow. So what a circuit really is a way for electrons to move from point A to point B and all the way back around. So it's like a circle that they're going to follow. It's really important that there are electrical parts like a light bulb, batteries, and wires, and we'll talk about those in a second. The light bulb, in this case, would provide some resistance in the circuit. If we don't have any resistance in a circuit, we get something called a short circuit, and that can be very dangerous. The battery is our voltage source, and the voltage is going to provide the push for the electrons. So the higher the voltage, the stronger the push for the electrons. And the wires provide the pathway for the electrons to flow. They're where the current is going to be found. So that connection then allows those electrons to flow, and it cannot be interrupted, meaning it has to be continuous. There can't be any breaks in the path. Down below, we have two examples of circuits. One has open above it, one has closed. You'll notice that the open circuit, the light bulb is not lit. In an open circuit, there is a break in the circuit. When we use light switches, we're actually opening and closing the light switches or the circuits. So when a light switch is turned off, the circuit is broken and it is open. This means electrons cannot flow in that pathway. Closed then means that the circuit is complete and there is a complete pathway for those electrons to flow. There are two main types of circuits. They are the series circuit and the parallel circuit. We're going to talk about those in just a bit. So a series circuit is a very simple circuit where the parts of the circuit form one pathway for the electrons to flow. Electrons can only go one direction and they can only go in one pathway. So it can't skip anything and it has to go through the whole complete thing. All devices share the same voltage and the current stays the same throughout the whole system. And that means if one item in a series circuit, for example, like the picture below, if one of the light bulbs were to break and the circuit would be broken, all right, or open, all of the light bulbs would go out. So in that series circuit, what happens to one piece will happen to all. You can think of series as same because everything that happens in a series circuit happens to all of the different pieces. Parallel circuits are a little bit different. Parallel circuits provide more than one pathway for the electrons to flow. The current can be different, but the voltage across each device is going to be the same as the source. So if this is a 9-volt battery, each device will receive 9 volts. Now the current through each device will have to depend on the resistance of each device. One light bulb might have a higher resistance than the other, and that would change the current through that device. But the nice thing about parallel circuits is if one of these light bulbs were to go out, the other two would remain on. That's why it's nice to have a parallel circuit, and most things are wired in parallel circuits. So you can think about parallel as individual pathways or multiple pathways for electrons to flow. So let's take a look at some examples of pathways. If we look at a series circuit, a series circuit is going to consist of some sort of resistor, in this case a light bulb, some sort of wires that's going to allow the electrons to flow, some conductive wire, and a voltage source, the battery. So when we have the switch open, right, it is an open circuit and no electrons will flow. If we close the switch, now there's a pathway for electrons to flow, and we have our light bulb lighting up. If we open the circuit again, there is no longer any pathway for those electrons to flow. If we add a second light bulb to this circuit, the voltage again is going to be shared. So this battery has a 9-volt battery. Before, 9 volts were going to this one resistor. Now that 9 volts will be split in two to 4.5, and each light bulb will receive 4.5 volts. This will result in dimmer lights. So as you add resistors to a series circuit, the current decreases in the whole thing. If we make a parallel circuit and we provide multiple pathways to flow, for electrons to flow, we get a little bit different result. So with the same components, a light bulb and wires and a voltage source, we can create a series circuit. By closing the switch, we have one pathway for electrons to flow, and we light up the light bulb. But now by adding a second pathway, we are going to provide another pathway for those electrons to flow. So when we add this light bulb, even though it's the exact same resistance, 10 ohms, 10 ohms, 10 ohms, 10 ohms, as the others, right? These lights in the series circuit will be significantly dimmer. That is because each pathway gets the same voltage. They both get the whole 9 volts. That means the current passing through them will be quite a bit higher than over here. Remember, an ammeter is used to measure current. So if I stick the ammeter in, I can measure the current, 0.9 amps. Because the other light is as bright as this one, it is getting the same current. And you see that adding this light back in does not change the brightness of that bulb. If we open this one up and stick the ammeter in here, we're going to notice that it is half that same current, 0.45. If we get rid of this light bulb, we'll see that now our current is back at 0.9 amps. So by adding more resistance in a series circuit, we decrease the current through the whole thing. By adding more resistors in a parallel circuit, we do not affect the overall current. If we increased this one to 15 ohms or 45, we notice that this one now is slower because it has that same 9 volts going across a much larger resistance. It does not affect this one. And that is the perk of having parallel circuits. You can have different resistors and they get the same amount of voltage. If you have any questions, talk to me or Mr. Oleg. Otherwise, have a fantastic day, everybody.